Hey everyone, my name is Sebastian, and I'm CTO and co-founder of dcSpark, a crypto ecosystem builder company. And in this video, I'm going to talk about the upcoming Babbage/Vasil hard fork for Cardano and what changes are being introduced to the protocol. Notably, I'm going to talk about the changes required for wallets, exchanges, and dApp developers, and really anybody building on top of the core Cardano protocol. And obviously, these will be nice to know for any power users who just want to know more about how Cardano is changing. And again, this video is brought to you by dcSpark, a blockchain ecosystem builder. Our company builds blockchain protocols, we build developer tooling, and we also build user-facing products. So notably in this upcoming Vasil hard fork, there's going to be 5 changes that you have to know about if you're a developer on Cardano, and then 4 changes that you don't really have to know about, but that you might be interested in anyway. So actually, the 5 major changes I just talked about are all kind of summarized in this picture. And in this video, I'm going to go over them one by one so that you know exactly how and if you need to update your application to take advantage of the latest functionality being introduced. So the first thing I'm going to talk about is collateral return. And this affects notably wallets and dApps. So if you've ever used a wallet like Flint, Nami, Eternal, you'll remember that to interact with dApps, you'll need to set collateral first. And this collateral is basically in case that the transaction that is using Plutus fails, it will basically consume your collateral as a fee. And there's 2 problems with the existing collateral system in Cardano. One is that setting a high collateral is kind of unsafe because if you call a malicious dApp, they could fail on purpose. And obviously this is not ideal. And the other unfortunate restriction was that you could not use UTXO entries that contained tokens in it. It had to be ADA only UTXO entries. So this made kind of setting collateral a user side issue that they had to deal with inside the wallet, which is not really ideal. So we introduced a feature called collateral return, which is basically when you set collateral inside the Cardano transaction, you now have 2 extra fields. One of them is the collateral return output, and the other one is the total collateral field. One example of this is that imagine you were setting 1,000 ADA as collateral. Now you can set a return of 995 ADA as collateral. And then this basically says if your transaction fails for whatever reason, that 995 ADA gets sent back to you as change. And the key insight is that if you're sending back as change and your collateral includes tokens, the tokens are going to be sent back to the user as change, and so that the fee they're paying in the end would just be purely in ADA. And so this kind of gets rid of the 2 restrictions we had on collateral previously, but the only thing you have to be careful is you have to make sure that the collateral is balanced. And what I mean by that is that if you're creating a transaction on Cardano, you need to make sure that the sum of the inputs is equal to the sum of the outputs plus the fee, right? This calculation down here. And the same thing has to be true for collateral. So you need to make sure that the sum of the collateral inputs is equal to the collateral output minus the required collateral, the actual collateral required by the protocol, which you can remember compute by yourself based off certain node endpoints. And then the other thing is that note that there's only a single collateral. Note this is not a list. It's just an optional field. So it does mean that you have to be careful about the max UTXO size, and you also have to be sure to satisfy the minimum UTXO value requirement. So that's collateral output. And there's another small change that exists, which is that previously your collateral had to be larger than the transaction fee times this collateral percentage protocol parameter, and that is just being changed from a regular greater than equal to a ceiling function. And the second constraint down here is just the sum requirement that I just mentioned earlier. So that's the collateral change functionality. And next we're going to be talking about reference inputs. So what are reference inputs? One of the problems with Cardano right now is that it's not easy to do an oracle. The reason why is because every time you use an UTXO entry as an input in Cardano, it consumes the UTXO and then you have to recreate it. And this is not great for oracles because it would mean that an oracle would only be usable once per block. And this doesn't work well if a lot of smart contracts are all trying to access the same oracle. So as a way to solve this, there's a new functionality called reference inputs that's being added, which is a way to reference UTXOs. And note that when I say UTXO, it means it has to be unspent. Reference UTXOs without spending them. And what this basically allows is to have multiple dApps referencing the same oracle data without having to actually spend that UTXO, but that oracle can still update that UTXO whenever they want, and whenever they update that UTXO, they'll still cause the deterministic failing of transactions that we want from the UTXO model. So that's why referenced inputs must be unspent. And note that if you reference an input, you actually do not need a witness for it, right? You're just referencing that input. You don't need a witness. And the other thing to mention is that this functionality is only going to be available from the Plutus v2 context. So there's actually a new version of Plutus, and you'll have to be using this new version of Plutus to take advantage of this functionality. Next, we're going to be talking about a similar feature called reference scripts. So another problem with Cardano right now is that whenever you're interacting with the smart contract, you have to re-upload the smart contract to the chain, and this is wasteful and causes the transactions per second of Cardano to be reduced, because a lot of the transaction bandwidth is just taken up by uploading the same script multiple times for popular dApps. So what reference scripts allow you to do is inside a transaction output, you can add a script, and note this is not a script hash, it's the actual script directly inside the transaction output. And then you can use this in combination with the reference inputs functionality I just mentioned to basically have one UTXO that holds the script for your dApp. And anytime somebody wants to use your dApp, they basically have a reference input that references the UTXO that is inlining their script. And then basically what this means is that you can reference the scripts multiple times, but it does have to have the same constraint as the reference input, which is that it must be unspent. And then again, you do not require a witness, so you no longer need to add the script hash to script witness in your transaction. And then again, this can only be done from the Plutus v2 context. Again, another similar feature to reference scripts is this concept of inline datums. So previously, if you were writing a smart contract in Cardano and you want to have data available to the smart contract, you had to post a datum hash inside the output and then provide the hash to data mapping inside the witness. This is no longer required now that we have inline datums, which is another option for you to inline the data inside the UTXO directly. Notably, this is much cheaper for small amounts of datum, notably smaller than the hash. And it's also good for data availability for dApps on Cardano, because one thing that you can do is you can enforce at a contract level that inline datum is being used. And so you no longer have the problem where it's possible for somebody to accidentally stall a dApp, depending on the architecture, if they were withholding the datum that matches their data hash. Now the application can enforce the presence of inline datum to make sure the data is present and the application can continue to function correctly. And then again, this means that if you're using inline datum, you do not need to provide the hash to datum mapping, even if you're using these as inputs in a transaction. So as I mentioned, there's now two versions of Plutus. There's Plutus v1, which is the old version, and Plutus v2. As I mentioned, if you're using any of the new functionality, you have to use Plutus v2. If you're still using the old functionality, you can continue using Plutus v1, or you can change the tag to be Plutus v2. And changing to Plutus v2 also has some other changes that I'm going to go over now. So first one is that the Plutus context changes. So remember, the Plutus context is the context you have available and then you can access from inside Plutus contract execution. So notably, you can see that you now have access to the reference inputs, and you also have access to the new value of transaction output. So although the type looks the same, the content of transaction output now contains this inline datum, and this reference scripts that I just mentioned. Two other changes that are also happening is that the types are being changed from lists to maps. So you can see that withdrawal types are now a map from state credential to integer, and the data map is now a map from datum hash to datum instead of being lists. So this is one key change. And the other change is that redeemers are also now available from inside the Plutus context, but note that the execution unit budget of these is not available, but just the redeemers themselves. So these are two extra changes now available to Plutus context beyond the new features being added in this hard fork. This new version of Plutus comes with a new Plutus cost model. The encoding for the Plutus cost model this time will be much simpler. It should just be a simple definite length list. So if you were relying on some custom odd logic to parse and generate cost models for Plutus v1, you won't have to deal with these for v2. The other thing is that scripts with Plutus v1 actually generate a different address than Plutus v2, even for the same script. So note that if your dApp is currently using Plutus v1 and you want to migrate your dApp to use Plutus v2, note that the hash, the script hash of your dApp will change. The reason why is because the script hash, which is used for the address, is actually prefixed by a byte that indicates which scripting language you will use. So 0 is native script, 1 was Plutus v1, and then there's going to be a new prefix 2 for Plutus v2 script. So just know that the address will change. Because these are considered kind of separate languages, these also appear at different places, both inside the transaction witness set and inside the auxiliary data. So note that you cannot submit a Plutus v1 witness for a Plutus v2 script. These are going to be separate entries inside the witness set that you build when building a transaction, for example, with the Rust SDK. Now, so that kind of completes some of the core changes. Another change that you may have to deal with is actually a change in the minimum value calculation. So whenever you are submitting a transaction to Cardano, every UTXO has a minimum amount that it needs to include, and that minimum value is changing. So it used to be a very complicated function that fortunately SDKs would handle for you, and it's now changing to simple serialization. So to explain to you the new formula, first I'm going to kind of go over some basic stuff to make sure we're on the same page. So remember that transaction input is a transaction hash and an index. A transaction output is an address and an amount. And a UTXO is a combination of a transaction input and a transaction output. Okay, so a transaction inside Cardano, which is a transaction hash and index, is 40 bytes of on-chain data and then 120 bytes of Haskell overhead. Note that the Cardano, the core node is written in Haskell, and so this constant is kind of hard-coded. So that means that the new minimum value calculation for Cardano is that it has to be larger than this constant 160 plus the serialized binary size of the transaction output component. Because remember, a UTXO is input and output, so we're saying this part is 160 constant, and this part, the transaction output, will just be the serialization size. And remember, if you wanted to see the old definition was sorry, this complicated function where UTXO entry size, data hash size were all these complex calculated values, and so this value will be much simpler. Again, you won't really have to interact with this change too much, because most likely you are using, for example, the Cardano Rust SDKs like CML, and then CML will handle the serialization size, min value size calculation for you. So you don't have to think about it unless you're writing a library that creates and serializes Cardano transactions, then you'll have to know about this, but otherwise it should be handled for you by the libraries. Another change that you don't need to know about, but you might be interested in, is the removal of the D parameter, otherwise known as the removal of the overlay schedule. So this is kind of some history for people who are interested. Cardano used to be centralized. They had a centralized release called the Byron era, that was meant to basically allow Cardano to launch while the research was still being developed. And then Cardano switched into the Shelley era, which was moving to decentralizing the block production of the protocol. And during that time, instead of making a binary switch from centralized directly to decentralized, there was instead a progress where every epoch it would become more and more decentralized, where more and more blocks would be created by the community instead of decentralized pools. And this D parameter was used to basically control which percentage of blocks were created by the BFT nodes and which percentage of blocks are created by the community. And since the Shelley era is now long gone and we don't need this D parameter anymore, the D parameter is being removed, and this simplifies the overlay schedule calculation. Another change that's happening that's very technical is that Cardano relies on something called verifiable random functions. I have a video on the topic if you want to learn more about what these are and how they work at a mathematical level on my personal channel. And Cardano basically requires 2 VRFs per block. One of them is the proof that you have the ability to create a block. Your stake pool is the one of the elected stake pools for this block. And then a second VRF to help contribute to the randomness of Ouroboros to avoid stake grinding attacks. And having to have 2 VRF calculations was expensive. And so IRIScape produced a new research paper that describes how they can combine these 2 VRFs together into a single VRF to speed up this calculation inside the protocol. Next, also related to the D parameter removal, there's going to be a removal of the protocol parameter called extra entropy. So what is extra entropy for those who want a kind of a historical lesson? So basically all blocks used to be created by these 3 entities, IOHK, Emergo, Cardano Foundation. And basically when we switched to the decentralized mode, we wanted to be able to prove to people that the centralized entities that used to be creating blocks did not skew the randomness inside their favor. And the way that we were able to do this was introduce this extra entropy field that impacted the kind of initial randomness to prove that the randomness was not compromised by the C key holders from the Byron era. Now that we were already in the Shelley era and that era is gone, we don't need this anymore. So we can now remove the extra entropy because block creation on Cardano is entirely decentralized, and so there's enough stake pools contributing to the entropy every epoch that we don't no longer need this extra entropy parameter. And then lastly, this is kind of a bug fix, which is we're removing this kind of overly aggressive pre-filtering of unregistered stake credentials. What this means is that it used to be that if you unregistered your stake credential partway through the epoch and then re-registered it, there is a case where your re-registration would not come into effect right away. And notably, this had to do with the reward calculation function in Cardano, which is not done on epoch boundaries, but done during the epoch and then applied at the epoch boundary. This was causing an issue where it would accidentally remove people even if they've re-registered. So this was kind of like an overly aggressive pre-filtering, and then the solution was basically avoiding this aggressive pre-filtering that should solve the issue. I'll say there's very few people affected by this, but it's still an issue that has been resolved. And then lastly, you might be wondering in this video what happened to pipelining. You might have heard of Cardano introducing pipelining during Vasil as a performance improvement. The reason I'm not mentioning it is because the pipelining change is not a strictly speaking Vasil change. It is an improvement to the Cardano node, and it does not require a change to the protocol itself. So it's not strictly speaking Vasil, it just coincidentally happens around the same time, which is why I'm not going into too much detail in this video. And that's it. So if you want to learn more, you'll be able to find the link to the slides inside the video description, and then the Cardano Ledger repo, where you can see the link right here, has the full Cardano specification there, including all the changes for Vasil. So if you want to learn more about Vasil, all the changes in detail, definitely check that out. One thing I didn't mention is that you might notice there's two names, Babbage and Vasil. Babbage is the name of the Cardano ledger change. Vasil is the name of the hard fork. So they're two different names for kind of similar concepts, and you could, if you don't want to think about it, you can just imagine they're the same thing, two names for the same thing. So just heads up on that. And again, if you want to learn more about blockchain tooling, where blockchain is going, feel free to follow us on Twitter at dcSpark_IO, where we post a lot of content about all the stuff we're building and our what we think is the future of blockchain. So thank you very much.